Recording started.
The recording has begun. All right, welcome to the July 22nd edition of the study hall. We have two topics for today on the menu. One of them is, as promised earlier, is percent problems. We're going to do a few of those. And I know a lot of you are probably saying, well, I already know how to work with percents, but there are probably some surprises in store for a lot of you guys. And then a number of you have submitted some questions about timing considerations. I got submissions from about 4 people at least, about some in previous weeks and some now. By the way, guys, your submissions, if we don't do them in the current study hall, we may well take them into account in future study halls. So we have a number of emails from the last couple of weeks where people were asking about questions with timing considerations. Either how do I stay on time, how do I make sure I'm on time, and or things like what do I do if I get behind my timing schedule. So someone in the text box put where do we get the archived videos? You get the archived videos on that link that I just put there on the left. So, okay, some people are messing around with video stuff, so I think I'm just going to go ahead and disable that just to make sure that the session doesn't get crazy here. All right. Smiley face if you guys can still see the screen. Okay, you can still see the screen. That's good. All right, let's go ahead and get started. So as usual, if you've attended the previous study halls, you will know this. It's like the way that when you get on an airplane, every single time you get on the plane, you have to hear the usual safety warnings. They show you how the seat belts operate, etc., all this other stuff. Same thing with the study hall. Every time we open the study hall, we have to have these opening words about question submissions. So here's the usual warning. Just think of it as the safety lecture that you get when you get on an airplane. So what kinds of questions do we want? Remember, you got to try to strike a balance between too general and too specific, because too general is stuff that we can't answer. I mean, every week we have a couple of people submitting questions that are like, you know, every time we have a couple of people submitting questions that are like, how do I do geometry? You know, or something like that. That is way too general. We can't address things like that in a study hall because that's, you know, I mean, there's a reason we have a 200-page long strategy guide on geometry. Some people have even submitted questions like, how do I do math problems? You know, which is, we have thousands of pages of material on that. Yeah, this slide for some reason is fuzzy. I'm not really sure why, but yeah, this slide is fuzzy. It's not the board in general. Like, for example, this should not be fuzzy, but this is. It has to do with the fact that I've reproduced this slide from last time and it doesn't capture it well. Okay, not too specific though either. A lot of people submit problems that are like one answer choice of one problem, which we don't want to do that. Like, if you're submitting a question that says why is choice D wrong on this problem, you should post that on the forums, manhattangmat.com/forums. That's what the forums are for. And remember that every problem that is an OK submission here is also an OK submission on the forums. And then lastly, you don't want questions that are too personal. This is not the place to submit questions like, I have a 610 and I want a 700, and here's my study history and here's my preparation history. This is not the place for submissions like that. those, again, we have a folder in the forum that you should use for those. That is the general folder on the forum. Or if your question is specifically about business school admissions, then we have another folder on the forum which is called Ask an Admissions Counselor. So, okay. Finally, sources. We say this every study hall, but people still violate it routinely. You have to cite a source for the problem. So you've got to tell us where the problem is from. That means original source, like who actually wrote the problem. So on other forums, you can't use. You can't use OG because that's a copyright violation. The GMAT people don't want us using the OG problems, so you can't use those. But then also, it looks like somebody opened a desktop share. I'm trying to kill that window. Okay. You can't use the OG problems because we're not allowed to use those, and you have to say where the problems you are submitting are from. Original source name. So this also means you cannot say, I got this problem off Beat the GMAT, because that's not an original source. Beat the GMAT doesn't write their own problems. They contain problems from a bunch of other sources. And again, this goes even for problems that are from our materials, same thing. You still have to tell us, because we don't, even we don't know all the problems in our own materials off the top of our head. So not too general, not too specific, not too personal, and please cite a source. Any questions, smiley face if you guys are okay with all of these guidelines, and we'll move on. Okay. Good to go. Let's take a look at today's material. I'm going to give you a problem. And on the problem, what I'm going to do is the usual. I'm going to give you A through E choices. Here's the problem. When you answer the problem, if you've attended previous study halls, you know how this works. Please answer the problem with the A through E buttons on the left. They should appear below the list of names. Okay, the other people will not see your answer once you've indicated it, but do not type your answer in the text box. Okay, I'll give you about a minute and a half. Again, as I just wrote in the box, do not type your answer in the text box. Thank you very much. Yeah, again, there are A, B, C, D, E buttons right over there, underneath the list of names. You can click those. Okay. Overwhelmingly, you guys are getting this right, although there are a handful of people who are not. Let's go ahead and talk about it. The correct answer to this problem is actually B, like boy. Does anybody know? Go ahead and type in the text box, how can you start this problem? Let's wait to get a few responses. Okay, one way to do this problem is to pick a number as the original value. So let's look at that approach, and then we'll come back and revisit a textbook style approach. So one approach is to pick a number. So our starting value is 100. 100 is an excellent starting value because it's compatible with percents. This works very nicely. So after you raise it by 50%, you get 150. And then you lower 150 by 50%, by 40%. 40% of 150 is 60. So final result is 90. So you went from 100 to 90, which means that you are now 10% lower than the original price. Okay, so one approach on this thing is pick a number. Remember, we want to rephrase everything in terms of takeaways. So takeaway here is that if a problem asks you to take percentages of an unknown value, then you can pick 100 or multiples of 100 for that value. Okay, so this is starting out apparently what is pretty basic for you guys. Sorry, there's a lot of noise in the background. I hear a helicopter noise outside, so not much I can do about it if you guys can hear that. Okay, so smiley face if everybody understands this approach in which you are picking 100 for the value because the value is unknown at the start of the problem. Okay, now there's two more takeaways that we want to get out of this problem. Again, remember that easy problems can still give you very useful takeaways that you can then utilize on later problems. One extremely useful rule here. This problem is generally not considered very hard yet. It wouldn't be the bottom of the barrel, but it wouldn't be, it's not considered super difficult either. Okay, one extremely useful rule for you guys is, in fact, I'll publish the statistics to the board. Here's the statistics with which you guys answered this problem. So most of the study hall got this problem correct. As you can see, a very strong trend in favor of B. Okay, one extremely useful rule here is don't pick sucker answers. Does anybody know what I'm talking about by sucker answers? What in this problem would be a sucker answer, and why? Go ahead and indicate in your text box. Yeah, the sucker answer to this problem is D, like dog. In this problem, the quote sucker answer is D, because this is what you would get if you could just subtract 50 minus 40. So the general rule on the GMAT is, on this test, you should be extremely suspicious of any answer choice that you can get by just taking two or more given numbers and adding, subtracting, multiplying, or dividing them. In other words, you should always have to do more than just simple arithmetic. So this is I mean, as far as if you had to guess, I don't think a lot of people had to guess on this particular problem. But if you had to guess on this problem, then the answer that you should absolutely not guess would be D. Because D is like the schoolboy answer. It's like the answer that you would pick if you really didn't have much of an idea what was happening here at all. And then you just said, oh, okay, well, 50 minus 40. So basically, if all you're doing is subtracting numbers, you should be extremely suspicious. Smiley face if this makes sense to you guys, and we'll move on. Okay. All right, now here's some new considerations. Let's go ahead and just do that right now. What's the quickest way to raise x by 15%? Does anybody know? Yeah, a few of you are writing it down in the box. Excellent. Okay. So the slow way of doing this is to take x and then add 15% of x. So that would be x plus 0.15 of x. But then you can simplify that. That's 1x plus 1.15x plus 0.15x. And then, so that gives you 1.15x. So in other words, what we've discovered is to raise a quantity by 15%, you should just multiply by 1.15. Okay, notice this pattern applies for other percentages as well. Same pattern for other percents. So let's say if you wanted to raise something by 40% in the text box, what would you multiply by? You'd multiply by 1.40. What if you wanted to raise by 4%? Then you would multiply by 1.04, watch the decimal places. And then what if you wanted to raise something by 150%? So a couple of you now are not getting this right. Notice the deal is that this is not taking 150% of something. This is raising it by 150%. Like, the reason why these work is because after you raise something by 40%, you have 140% of what you started with. Same thing, after you raise something by 4%, you have 104% of what you started with. Yeah, well, after you raise something by 150%, you actually have 250% of what you started with. So another way of looking at it is like you're taking 100 and adding this number and then making it into a decimal. So you get 140% of what you started with, that's 1.4. You get 104% of what you started with, that's 1.04. If you raise something by 150%, then you have to multiply by, now you have 250% of what you started with, so that's 2.50. If you wrote 1.50, which some of you did in the text box, if you multiply by 1.50, that's only a 50% increase. Because that works the same way as these do. That works the same way as 40% does. Smiley face if that makes sense. Okay. Other face if it doesn't. Okay, we're seeing mostly smileys. All right, now what about decreasing a value by 15%? Yep, okay. 0.85 because again, the slow way to do this is to work it out. Like the slow way is to say x minus 15% of x. So that's 1x minus 0.15 of x. So times 0.85. So to decrease a quantity by 15%, you multiply by 0.85. I mean, the idea here, again, this should make sense intuitively. If you take away 15%, then you have 85% left over. So that's why this is 0.85. If you take 15% of something away, you get 85% left over. So a couple more just to make sure we're on the same page. To decrease a quantity by 94%, what would you multiply by? Okay, good. Now, quick test. Let's say you wanted to, how would you write x has been increased by 10%, and then the result has again been increased by 10%. Text box, please. How would you write that? Okay, yeah, a lot of you guys are getting this correct. Again, what's cool here is just that you are taking an x, and then the first increase of 10% is just multiplying by 1.1. So that's 1.1. And then when you multiply the result by 10%, then you've got another 1.1. Because each percent increase becomes a multiplication. Notice you don't need to add anything ever in order to accomplish percent increases, which is actually very cool. Okay, questions? Questions, go ahead and type in the text box. Then let me give you two more rules that you can use here, which are the following. If you want to increase something by a variable percentage p, I'll just tell you how to do that. If you want to raise something by p%, then you multiply by the following quantity. 1 plus the fraction p over 100. And then if you want to decrease it by p%, then you multiply by the quantity 1 minus p over 100. You don't say, the question in the box is how do I save the slides? You don't save the slides, but there are recorded archives at the same website where you submit questions and log in. So, okay. Any questions about any of this stuff, go ahead and ask them. Otherwise, we will move, actually we will temporarily move back to the other problem. But then we'll move forward. No questions? Okay. A couple of you guys are typing, it looks like. So, let's see what you guys are typing. While you guys are typing questions, let's apply this to this other problem that's right here. If you remember this question, let's do this the textbook way as well. We'll get that one in a second. The textbook solution to this would be original price is X, and then after you raise the after the 50% increase, you'd get what? Text box. You would get, well, it's not just 1.5. It's 1.5 times X, yeah. So you have to multiply by 1.5x. And then after you decrease this by 40%, you get, how do you decrease something by 40%? Text box, yep, you guys are starting to type it. If you decrease something by 40%, you have 60% left over, so you multiply by 0.6. So notice that both of these things are in there. You've got the raising the price by 50%, that's what this does, and then lowering the price by 40%, that's what this does. And so then if you just multiply that out, you get 0.9x. But then for the same reasons, and for the same reasons that these work out the way they do, you use the same kind of reasoning, only now you use it backwards. Using the same reasoning backward, you figure that multiplying by 0.9 is a 10% decrease. So the answer is B. Any questions? If you have questions, go ahead and type them. I'll get that one in a second that you have. All right. Anything else? The question of does it matter which way you multiply? No, it doesn't. I mean, multiplying, you can multiply numbers in any order you want. It's going to work out the same. I mean, these are decimals, but decimals are not different from other numbers. So if you, like multiplying 2 times 3 times 5 and 3 times 2 times 5, you're not going to get different answers out of that. So same thing if you multiply this times 1.5, then times 0.6, you're not going to get a different answer than what you would get if you did it in the other order, because it's still just multiplying 3 numbers together. The question here, if you raise something by 40%, that's a multiplying by 1.4. So therefore, raising by 50% would be a multiplication by 1.5. So that can help you sort out the confusion in the case of raising something by more than 100%, which will be rare, by the way. But raising by 150% can't be just 1.5, because that's this. That's only a 50% increase. Okay, smiley face if this stuff makes sense, and then we'll move on to some stuff that's a little bit more challenging. Okay, again, people were posting about saving slides. You can't save the slides, but these recordings are all archived on the website, so you shouldn't have to save the slides. Okay, let's move on. Here's a quick check. Luis takes a value x, decreases it by 20%, and then increases the result by 30%. Pilar takes the same x and she increases it first by 30%, and then decreases the result by 20%. So I've given you options at the left. You should see buttons for green check and red X. If you think the two results will be the same, then pick green check. If you think the two results will be different, then pick red X. I'll give you a little bit of time to do that. Okay, most of you still haven't answered this. Please, everybody, give me some kind of answer to this if you think they're going to be the same versus if you think they're going to be different. The red X and your green check are over here. If you think they're going to be the same, give me the green check. If you think they're going to be different, give me the red X. Some of you guys are giving me smiley faces. Now we want. We want the green check or the red X. Okay. So still about 20 of you that haven't given me an answer yet. Okay, no, there's no timer because this is not like a GMAT-like problem. Okay, some of you guys, maybe you're not here right now or something, but here is the results. This is actually pretty good. When we do this in class, most people tend to get this wrong. But it turns out that the results will be exactly the same. Now, who knows what the overall percent increase will be? Go ahead and type in the text box. Very good. So it's not 10%. So the overall increase will not be 30 minus 20 equals 10%. Who knows why the results are the same? Go ahead and indicate in your text box, why will you get the same result? Yeah, I mean, this is the text box. You guys have the answer. We'll type it here in a second. But some people really don't want to do these. Like, some people are still content with, like, oh, if I want to raise something by 15%, then I'll just take X and add 15% of it. Well, the problem there is that that's very slow, number one, but number two, it will not tell you why this kind of stuff works the way that it works. Whereas, if you know how to use the percent multipliers, it becomes very clear why this works. So if you understand the percent multipliers, the reason is clear. So if you're Luis, then what you're doing is you're taking your X, and then first you are multiplying the X by a 20% decrease, so that's times 0.8. And then after you do that, you're increasing the result by 30%. A 30% increase is just multiplication by 1.3. So relatively painless. And then if you're Pilar, then what you're doing is the exact same two multiplications, but you're just doing them in the opposite order. So Pilar multiplies by 1.3 first. And then afterwards, decreases the result by 20%, which is multiplying by 0.8. So both of these, pardon, that's supposed to be in parentheses facing the other way. Both of these are definitely going to be the same. In fact, you don't have to actually figure out what the number is to realize they're the same, because multiplication works the same way in any order. So you will get the same result. And if you want to be specific about it, which you don't have to if it's just a yes or no question, but specifically the result is 1.04x, which means an overall increase of 4%. Notice that 4 is not 30 minus 20. Any questions? questions? I don't think anybody is typing questions. So that's good. One more way that we can investigate this problem before we move on to something new. Here's the same problem. The other way you can investigate is by picking numbers, which is the same way that you investigated it. First problem that we had. Also investigate by picking numbers. So if you're Luis, then you start with x is 100. If you decrease 100 by 20%, that gives you 80. But then 30% of 80 is 24. So adding 30% gives 80 plus 24, which is 104. And again, notice there's your 4% increase again. And then if you're Pilar, then you just do the same steps, but you do them in the opposite order. So you also start with 100. First thing you want to do is increase by 30%. That will give you a value of 130. But then you want to take 20% off of that. So 20% of 130 is 26. So subtracting this gives 130 minus 26, which is again 104. Beautiful. So the same. Again, notice the percent multipliers are extremely valuable, so do not stick to these hidebound ways of subtracting and adding percentages if you don't have to. Any questions? Okay, let's move on. For the next couple of problems, we're going to assume that you know how to do data sufficiency. Don't worry, we're going to get there. The next couple of problems we're going to do are much more challenging. So I'm going to give you 2 data sufficiencies to hack away at. I want you to do both of the problems. Now, when you do these, you are not going to be able to indicate your answers to both. So for right now, just do both of these. Don't indicate your answers yet. Do not type them in the text box, and don't indicate them yet in any other way. And then at the end, we'll go ahead and poll you on both of them. So try these. Because they are similar problems, I'll give you a little bit less than 4 minutes, but I'll give you, say, 3:45. Okay, again, for now, keep your answers to yourselves. Have fun. Okay, good times. Most of you, thank you for following directions. To the person who wrote their answers in the text box, even though I said don't write your answers in the text box, please don't do that. Okay. Let's take a look. The first problem, I've just given you A through E choices. So go ahead and indicate your answer with those A through E buttons for this problem. Okay, and I don't know if this is going to change anybody's answer. I should have specified this, I suppose, but in both problems, X and Y are positive. Is that going to change anybody's answer? If it is, then tell me in the text box and I'll give you some additional time. If anybody's answer is going to be affected by this. Because the GMAT's not, I mean, the GMAT's not going to do this to you. So you're not going to talk about raising the price of something by like -5%. Okay, so we're all good. All right, now everybody give me an answer to this. About half the class here still hasn't answered this problem yet. So let's take a look. If you have to guess, go ahead and guess. We've still got about 10 or 12 people who haven't answered the problem yet. So, okay. 5 more seconds to put a guess up there. 4, 3, 2, 1. Okay. Here are your answers. Whoops. It didn't work. Here are your answers. Right there. Now, I'm not going to tell you who's right and who's not yet, because we like to keep things interesting here at Manhattan GMAT. But I will tell you that the answer is not D, and it's also not A, which is, as you can see here, that's the vast majority of the answers. So let's talk about this. What's the temptation to pick A as sufficient? See if you guys can type in the text box. I mean, like, what's the reason? It gives you specific values, yeah. Although, I mean, I could give you other specific values that you would probably not think are sufficient. But the temptation here is that, I mean, the temptation here is just to think, hey, you know, that's a bigger value. Yeah, it's a bigger increase than decrease. But let's investigate, because it's not that simple. So we might try algebra in a second, but let me just show you with specific values. Let's take 100. Let's look at some examples. So let's just do, say, x is 20% and y is 10%. So try x is 20, y is 10. So you start with 100. Increase by 20% gives 120. And then you decrease by 10%. 10% of 120 is 12. So gives 108. So that's a no to the question, because the new value is higher than the old value. Now, somebody tell me in the text box, what are we trying to do now? Well, we just got a no to the question. So what should we be trying to get now? Does anybody know where we're going with this? You want to try to get a yes, because the deal is that any more no's are not going to do anything for you at all, because we already have a no. So now you should try for a yes answer. Well, does anybody know a nice, quick, and tricky sort of way to get a yes answer to this question? Well, you can't use one-to-one, because one-to-one is going to be a lie. Like, you have to satisfy statement 1. So if you pick 1 to 1, then if you use 1%, no, it'll still work out to be a no to the question. If you raise this by 1% and then lower it by 0.5%, it'll work out the same way as this one does. In fact, ironically, you guys are kind of going in the wrong direction. What you should be doing is Daniel's idea is excellent. It can't be 0 because here's your condition. Both problems have to be positive. So 100% decrease at the end, right? The reasoning is, look, man, if I can make the final value 0, then I'll definitely get a yes. So let's try x is 200 and y is 100. So if you start with 100, then increase by 200% gives 300. Then if you decrease that by 100%, then that gives 0. And that's a yes to the question. So that's insufficient. How about that? You don't have to use 200% and 100%. It turns out that if y is anything bigger than 50%, then it'll work out to be a yes to the question. So, yeah. As far as what level problem, I mean, I made up this problem, so to be honest with you, I couldn't tell you, but I intended it to be pretty hard. But remember difficulty levels. You guys who are veterans of the study hall, you will have heard me say this many times before. You do not care about difficulty levels. You do not care at all in any way. The only people who should care about difficulty levels are people who are at a very low level and who are working on problems that are too hard for them. Those are actually the only people who should care about difficulty levels at all when they study. Because otherwise, remember, you're just trying to learn stuff and apply it to other problems. And I mean, if you worry about difficulty levels, that's going to get in the way of learning things. Because remember, this problem you don't care about. I mean, but what you care about is things that you can learn from this problem and then apply to future problems. Okay, so, and I mean, even if you didn't come up with these values right from doing any kind of reasoning, the other lesson is that you should just try values. I mean, so the other lesson here, I mean, before you give up, you should just try a whole range of possibilities. So as far as how to know which values to try, you just want to try values that are different from each other. Like, so if you plug in 10 and 20, you don't want to plug in like 15 and 30 because that's too close. But some of the other people in the text box were kind of getting there, with it. They were like, okay, let's try fractional percentages. If you do try those, you'll still get the same thing you got here. But, so, yeah, 100% increase, yeah, is doubling the number. Because you're taking the number and adding 100% of it, that's precisely what that would be. So, yes. Notice here there's no 100% increase, but if you were going to do one, that's exactly how you would do it. Okay, but Kathy, yeah, you just want to try a bunch of numbers that are not like each other. Like if you fall into the trap of plugging in a lot of very, very similar numbers, then that won't be so good. Let's try algebra on this problem and see where it goes. I actually have never even tried. Yeah, if you can do those, yeah, definitely. I mean, fractional percentages are a good thing to try too. So statement 1 here is this. Let's give, basically extreme numbers is a better way to put it. So Marco, thank you. let's try algebra. I actually wrote this problem for this study hall, so I've actually never even seen how it works with algebra. Let's give it a shot. Let's try algebra on statement 1. Okay. On statement 1, so this means that you increase by 2y%, and then decrease by y%. So this means that you take whatever your number is. Let's say that p is the original value. So you get p times, remember it's 1 plus the percentage over 100 times 1 minus the decreased percentage over 100. So this is going to be 2y over 100, and that's going to be y over 100. So you would need to actually multiply this out, which is going to be a little bit annoying, but it's going to be p times. If you FOIL that out, you get 1 plus 2y over 100 minus y over 100, so that's overall is y over 100. And then you get minus 2y squared over 10,000. That's not my idea of fun, but, you know, it'll work. So the question is this greater than or, I mean, how do we tell, does anybody know, how do we tell if this is going to be lower than p? Does anybody know how we would tell? Yeah, what we have to figure out is what we're multiplying p by. Because I mean, if this is less than 1, then we get lower than p. So we need, you know, is all that stuff. Just trying to copy and paste. Alright. Whoa, that's not fun. Alright. So we're going to find out if that's less than 1. So that's what we're trying to figure out. Because then we'd be multiplying by a fraction, which would shrink the number. So that means we want to know the 1s will cancel out. So we get y over 100 minus 2y squared over 10,000. So that's like this. Zero. Actually, the 1 cancels out. So this is supposed to be a 0 over here. We can multiply that through by 10,000. That gives you 100y minus 2y squared is less than 0. Divide by 2 is less than 0. Factor it. This works if y is greater than 50. So yes, if y is greater than 50. No, if y is not greater than 50. So that's insufficient. I mean, that's kind of obnoxious. But it does work. I mean, it's possible. And I mean, again, I just wrote this problem about an hour ago, so I had no idea how it was going to work out. But the point is that if this is your game, I mean, again, the GMAT has a lot of problems. The reason why I'm going over this is that the GMAT has a lot of problems on which algebra is very, very difficult. Sometimes even impossible. But on which other methods work much more easily. So some other methods might include intuition, they might include estimation, they might include plugging numbers, etc. And there have been previous editions of the study hall in which we've done some of these methods. We talked about a lot of these methods on February 4th. So if you want to look at the archive of the study hall for that day for a thorough discussion of such methods, you can do that. But notice the algebra does work, but you've got to be an all-star at algebra to figure out how this works. Let's look at what's in the text box. I don't know what critical Y star means. So whatever that means, I actually have no idea what that means. Can you rephrase the question with X and Y? Whoever wrote the question about rephrasing with X and Y, it depends on what you're talking about rephrasing it into. I mean, this question is not that easy to rephrase, but you could certainly try. But notice that as far as the number plugging, that's what we already did over here. So this is an example of numbers that you can plug. Okay. I really don't have much of a background in formal mathematics, to be honest. So terms like critical value and stuff, I'm not really going to know what that stuff means. But thank you. Okay. Other questions in the text box? Okay, I think we're good. As far as what numbers to try plugging, yeah, try different kinds, different sizes of numbers like extremes. By the way, this investigation has actually solved the entire problem, because if we make our grid here, we've just found out that A is insufficient, but then the same values actually work for statement 2. I mean, so statement 2 is also insufficient. Same values work for together and for statement 2 and for together. So statement 2 is still insufficient because of exactly the same examples. And then together they're still insufficient because the same numbers still work for them both. So the correct answer to this problem is actually E. Okay, mind you that you could rephrase that, but then if you rephrase it that way, then you're absolutely committing yourself to this approach, which most people honestly will probably not finish in time. If you're very, very, very good at algebra, then you will. But if you do this, then you've just pretty much lost whatever chance you have of using this kind of approach where you're just plugging numbers. So be aware of that. I mean, you can try the algebra, sure, but then make sure that you can go back to just this if you need to plug in numbers. Okay, it's a bear of a problem. It's pretty tough, but everybody understand that. Everybody understand why is E? Give me a smiley face if we're all good there. Smiley faces, if we're ready to go. Smiley faces. All right, there they are. There's the smiley faces. Okay, let's look at the second problem. I'm going to clear your answers out. Please use your A through E buttons again to answer the second question. Second question, A through E. But again, you should all have answers for this. So, whatever answer you had, go ahead and give it to me, please. This problem, answers, please. Still more than half the class has not given me an answer. Remember to indicate with those buttons over there, those A through E buttons. Okay, we're starting to get answers here. Remember, guys, we did these problems like 15 minutes ago, so you should definitely have an answer for them, even if it's a guess. Please indicate an answer in the next 10 to 15 seconds. Thank you. All right, remember, if you don't, this is the GMAT. You have to answer the problems. So for those of you who are not answering the problems, yeah, but the GMAT will do that. If any of you guys are not answering because there's sort of a confidence issue here, you still have to get used to answering everything. You can't get into this mental frame where you are frozen in place. This is the GMAT. You guys are all going to miss a lot of problems. It's going to happen. So even if you're very good at this stuff, you're going to miss problems left and right. So what you guys have got to get used to doing is missing problems, getting knocked down on your back, and then getting right back up and answering the next problem. Yeah. So you got to let it work that way. Okay. Here's the answers that people have to this one. They're a little bit more spread out here. Actually, nicely enough, this one really is D. So you guys, at least the majority answered this one is correct. Let me show you a way that solves this, which is actually intuitive, where you don't have to plug in any numbers. Here's an intuitive approach. Even if you didn't have this intuition, you can still study it so that you might have this sort of intuition next time. So even if you didn't have this intuition yourself, you should still study it so that you might have a more informed viewpoint next time. Here's the difference. Okay, there's two steps here in this process. The first step is, so back, remember the last problem, the correct answer was actually this one. The first step is take an X, take a price, then raise it by X% of that price, and then lower by Y% of the new price. Okay, smiley face if you guys are all following that. Like, those are the things that are happening in this problem. Okay, let me show you something cool. So they tell us in this problem that Y is bigger than X. Actually, in both of these, they tell us that Y is larger than X. So that is a bigger percentage, and that's a lower percentage. So bear with me here while I type. This is a smaller percentage of, and this is a bigger percent of. And then notice the prices. Well, I mean, the original price is lower than this price because in this step the price has actually gone up. So, like, that's a bigger price and this is a lower price. So if you realize these items, then you know the amount by which you're going up is a smaller percent of a smaller number. And the amount by which you are going down is a bigger percent of a bigger number. So those are, the first one is definitely going to be less because it's a smaller percent and it's of a smaller number. The increase is a smaller percent of a smaller number. The decrease is a bigger percent of a bigger number. Therefore, the decrease will outweigh the increase. No matter what. So, and that's with anything where y is bigger than x. So these are both going to be sufficient. So in this case, you're going to wind up with an answer choice, D like dog, which actually a lot of you got. Although if you, this problem you guys might wind up with D for the wrong reasons in some cases. Because if you pick, like a lot of people pick D here too. So if the same people who pick D here are also picking D here, which I'd imagine didn't happen every time, but I'm certain happened in some cases, then you got the right answer for the wrong reasons. Stephanie, no, it can. For example, imagine if you have, imagine one person who has much more money than another person does, and then imagine taking like 40% of the rich person's income and then like 10% of the poor person's income. I mean, those are definitely never going to be the same. So, same sort of thing. If you, the question about up here, if you do this up here, then you won't be able to tell. Because if x is bigger than y, then the problem is this step will now be, raising it will be a larger percent of a smaller number, and lowering it will be a smaller percent of a larger number. And so those can go either way. Those could be the same. One can be bigger, the other one can be bigger. You can't tell. But in this case, you've got, you know, smaller percent of smaller number versus bigger percent of bigger number. So we know who's going to win. It's kind of cool. So, all right, what I will tell you is that I'm not going to go through the other methods. I'll just kind of tell you how they work, and if you want to do them at home, you can do them at home. The other methods are, if you plug, you should find that you get a yes to the question for all values of plugins, because you have to. And then if you do algebra, it should be similar to the other one, to the other algebraic approach that we did. Except the inequality should always work out the same way. So in other words, all the percentages from 0 on up should be the same on the inequality. So, but other than that, the algebra approach is going to look a lot like this one. Notice that you can't really do this with the straight inequality symbol, and that's very typical of the GMAT. I don't really know if the algebra approach will work with statement 2. The algebra approach you can do with statement 1 because you can substitute in 2x for y. But I don't know if the algebra approach will work at all for statement 2. It's an interesting question, but we'll leave that question open for now. Anything else about what is on this slide before we move on to 1 or 2 more items? Okay. It's good stuff. So, I mean, again, I know a lot of you guys were starting to be like, what's this percentages stuff at the start? I mean, because the first couple of problems, I'm sure, were easy for a lot of you guys. But this, yeah, these are hard. Okay. I guess I hope the people who are asking about slides were late to the session because I've already said this about 3 times. But no, you cannot print the slides and you cannot save them. But we do archive all of the sessions at the website where you submit questions. So you'll find the archive posted in about, I think, 4 days. It'll be a video archive. It'll be a recording of the session, so you can watch it then. But we don't let people save the slides. Okay, let's look at one more percent problem. Here you go. As usual, I'll give you a timer, and then when you are done, please indicate your answer using the A through E buttons. Left again. Thanks. So I'll give you a timer. I'll give you a minute and a half because it's not a ridiculous problem. We'll go from there. Okay. This one is this one's probably like a moderate difficulty problem if you guys are wondering. Let's take a look. Give me an answer, please. There's about 7 or 8 of you who don't have an answer, so if you're here, please answer. Okay. So mostly down to C and E. I think we can pretty much skip A and B individually because the individual statements are definitely insufficient, which the whole class realized that, so that's good. The individual statements won't do it because in each case you have no information whatsoever about one of the 2 components of the income. So, I mean, if you just have statement 1, then you don't know anything about classes, and if you just have statement 2, then you know nothing about books. So, question, smiley faces, that much makes sense. Okay, now, let me poll, I mean, people who thought the answer was C, how did you justify that? Go ahead and type in the text box. Then we'll poll the people who thought the answer was E in a second. So if you picked C, then what was your justification for picking C? And if it was a guess, then you could say that. But if you had any sort of reasoning behind it. Okay, so people are being sort of vague. Right now, I just want people who pick C. If you picked E, then don't answer yet. A couple people typing who didn't pick any answer. All right, so it turns out that, okay, well, let's hear from people who picked E now. If you picked E, then why? Yeah, the people who picked E, you've got the deal here. Because, I mean, the thing is that you're looking at the whole income. And the problem is we don't know how much of the income is composed of each of these 2 things. I mean, again, you definitely want to be intuitive about this, you know. Here's like an analogy. Like, let's say that my income comes from, like, say, factory work, which is like around 50,000 a year, and like Christmas gifts, which was around, like, let's say it's around 200 a year, you know. So the point here is, if that's the case, then, I mean, any change in my factory income is going to have a lot bigger difference, right? So, like, if my factory income goes down like 10%, then my whole income is pretty much going to go down by very close to 10%. Whereas if you take 10% off of my Christmas gifts, that's $20. So that's barely going to touch anything. So, smiley face if you guys understand this analogy. So this is the same kind of thing, and the point of this analogy is that it totally matters. It matters, like, how great the contribution is from each source. So, like, even if you have these two statements together, like, if close to 100% of, so let's take a look at C and E together. If close to 100%, like if almost all of the company's income comes from books, then the overall effect will be, you know, it'll be close to a 10% decrease. But if almost all of the company's income comes from classes, then the overall change should be close to a gain of 20%. So that's enough to give you insufficient. So this one is E. But if you want to plug in numbers, again, what you have to do is, if you want to plug in numbers, I think a lot of you, from what you're typing in the text box, I think a lot of you are still not realizing this. Remember that you cannot just plug in one set of numbers, okay? Remember that you must use multiple plugins if you are going to plug in numbers on data sufficiency. Okay, you cannot just plug in one set of numbers. Like the last few problems have been data sufficiency, like including these ones, and a lot of you guys have been typing stuff like, well, I'll just plug in 100. You can't do that. This is not problem solving. Like if it's data sufficiency, remember the deal is sufficient versus insufficient. The only way that you can tell whether something is insufficient is to plug in a couple of different values and see if you get consistent answers. If you just use one plugin, you will never be able to tell whether it's sufficient or not. So if you use this, let's just try different numbers. So let's try this with last year versus 1999 and 2000. And then let's say classes and books. So let's make it, in 1999, let's say it was just like 100 and 100. Then it went to, the books went down by 10%, so now that's 90. And the classes went up by 20, so that's 120. So this would be overall, you have from 200 to 210. So that's an increase of 5%. Okay, on the other hand, if you do something like, now let's do it with different numbers. 1999, 2000 classes. Whoops. Let's say we start out with $1,000 from classes and $100 from books. Now we're at 1,200, and now we're at 90. So overall, this is from 1,100 to 1,290. So that's an awkward percentage, but we know this is went up by more than 10%. Because 10% of this would be 110, and this has gone up by more than 110. So this is, we don't even have to find out the actual increase here because we know it's definitely not 5%. So this is a 5% increase. This is an increase of way more than 5%, so we are insufficient. Smiley face if that makes sense. So, how do we get to 5% increase? Well, with these particular numbers, it's the percent change in the total income. So this is not, there's no magic to it. You just add up the numbers and see what happens. So the total is 200 before, and the total is 210 afterwards. So Marco is just finding the percent increase between 200 and 210. So the increase is 10 divided by 200 is 5%. So, okay. If you were going to do this with algebra, I'll just give you the quick start to it. If you were going to solve this with algebra, it becomes, so yeah, the answer is E. Notice that it's indicated on here. The answer is E. We've got it boxed on there. Okay, with algebra, it becomes, in 1999, you have to use two variables because you have absolutely no idea there's no relationship between C and B, so you can't use one variable. So, and then in 2000, well, you've got books went up down by 10%, so that's 0.9B. And then classes went up by 20%, so that's 1.2C. If you try to figure out what's the percent change, well, the percent change is you have to do the difference over the original. That's how you find percent changes. So it's 1.2C plus 0.9B minus C plus B over C plus B. So the problem is that's not going to have a single value. That's going to reduce to 0.2C minus 0.1B over C minus B. So that's insufficient because you don't know. We don't know what that is. I mean, that's going to depend on the values of C and B. So there's your algebra approach. BMW, I cannot understand what your question says there. Could you type that again, please? And maybe check your spelling. Okay, let's see. BMW, you got to answer the question that's written there. The question is, what was the percent change? So if it says what is, then they mean exactly what they say. They mean what is this? They don't mean just is it positive or negative. It means what you have to find the exact percent change. Like that's what that means. So the one thing these guys don't do is like dissimulate with their words. They don't ask, they don't use words that are different from what they mean. So if they just want you to know if there's a decrease, then they will ask you a question like this. Is the new price lower than the original price? Then to answer this question, all you have to figure out is, does it go down? Because that's what that means. But if they ask you what is the percent change, then they mean that. They actually mean, they're not kidding, they actually mean what is the percent change. Like as a number, as an actual numerical percentage. So, BMW, does that make sense? Okay, good stuff. The other question, somebody wrote algebra versus plugging. It depends on who you are. I mean, some people wouldn't be able to do this that easily, but maybe. A couple of words about that. The first thing is that you shouldn't really be thinking too hard about which one is easier. You should just be able to do both. Because, for instance, on this problem, the intuitive approach was much easier. Like, the algebra was just horrendous on this problem. Remember this god-awful thing. But then on this other one, which honestly, this doesn't look like it's that different. I mean, they're both problems that deal with an increase and a decrease, and then whether things are, percent changes. And yet this one, yeah, the algebra here might be a little bit easier. So the deal is not which one is easier, because again, because then you're too focused on this particular problem. If the question is, by the way, people will be patient with the questions in the text box. I can only answer one question at a time. Thank you. It doesn't matter which one's easier, because that's just an issue for the particular question at hand, which is ultimately what we don't care about. Like, what you want to emphasize is knowing both of the methods, regardless of which one is easier in the problem at hand, because the next problem they throw at you, maybe the other one might be easier. The deal is just that you need to be able to do both ways, whether or not they're easier. The other thing is, the little hint here is, generally the more exact the question is, the better off you are with algebra. So for instance, here they want you to find the exact percentage. So this means, this is actually something that I can make a quick slide for here. In general, the more specific the question, the more likely it is that algebra will be easier than other methods. So for instance, consider the last two questions. If you have something like, is the new price lower than the old price? This is not that specific. I mean, it doesn't ask for a particular value. I mean, its solution is an inequality, which is sort of vague. Therefore, it's likely that algebra will be more difficult here. And notice that it totally was. Like, here's the problem with the lower than. And by all means, doing algebra on this problem was just horrible. It was awful. I mean, look at this. But then the other question was, what is the percent increase? This is a very specific question. So in this case, because you want a number, it's more likely that algebra will get you the answer. I mean, there are exceptions to this, but this helps to explain why the algebra was much less complicated on this problem, even though it might not, at first glance, look much different at all from the other one. Okay, smiley faces, these make sense. Okay, Paul, your question, if they give you another relationship, then if they give you another relationship, then you would be able to substitute in here, and so you would get sufficient. Like if they gave you the 10% decrease of books was 2% of the total income, that would mean that books were 20% of the total income, because if 10% of books is 2%, then books are 20%, right? So if that were true, then B would just be 0.2 of X, and C would be the other 0.8 of X. And so you can substitute. You get 0.8X, 0.2 times 0.8X, 0.1 times 0.2X, 0.8X, 0.2X. And then you get a whole bunch of X's, and they all cancel out. So in that case, you'd be good. Okay. So that works. Daniel, the question, so, okay, no. To any question at all, ever, with should I use this one method all the time, the answer is always no. Okay, make sure you know this. If you are asking, so should I use this method on this type of problem all the time? This is totally the wrong question to ask. I mean, this is entirely the wrong attitude, and I mean, it's a little bit worrisome because this is basically just what I got done talking about 2 minutes ago. Remember that you just want to learn as many approaches as possible. I mean, you really don't want to sweat thinking about, is it the better way, is it the worst way? I mean, honestly, you shouldn't care all that much about which is like the best or better way. I mean, you basically just learn as many ways as you can, and then on the test, if something works, then do it, and if not, then do something else. I mean, that's pretty much it. Like, you really don't want to try to memorize hordes and hordes and hordes of rules about this is the best way to do this, because that's the whole point of this test, is to kill people who think like that. You know, like, think about these. I mean, I wrote these two problems, but it's the same thing. Like, somebody might see this problem and say, oh, now I know that raising and lowering don't always give the same answer. If people just memorize that, then they're going to turn around and get this problem wrong because it looks the same. So these problems look almost exactly the same, but they have totally different answers. So this should totally throw a wrench in any kind of idea that there's a universal way to study for these things. I mean, the point is just you need to absorb as many ways as you can of doing these problems, and that's it. End of story. So, but in general, the answer to will this method always work, the answer is always no. No, it won't. There will be problems where that method will not work. That's how this test is. It's frustrating, but you gotta learn your enemy. Okay, we are over time by about 10 minutes. We got to cut it, but we will do timing next time. So I promised you this. This will now be postponed. Ironically, we ran out of time for timing. Ha 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 ha. So we will do this next time. We're going to stop the recording right now.